Good morning, everyone, and welcome to Katib's Autodesk Virtual Academy. I'm Nigel Mbayak, application engineer, and your host for today and just about all days here on Autodesk Virtual Academy. Good morning, everyone. And today I'm joined by Jorge Fernandez, who some of you may recognize as a frequent flyer, I guess, of this program.
Does that mean I get more bonus points or something?
Maybe you get a fly first class.
Let's hope.
Yeah, so you might notice we're in a different location today. We're actually in our training facility because we figured we'd write some equations on the board back there. You shouldn't be able to read them, but we've got a slide showing a few of them. So hopefully that goes smoothly here shortly. Today we're going to be going over some Nastran In-CAD. And for those of you who don't know what that is, that's a simulation tool from Autodesk that's built right into Autodesk Inventor, as well as some other CAD tools that Jorge will explain shortly. SolidWorks as well, and I believe Pro E.
That's right, yeah.
Yep, so we'll go over some of those details a little bit later here, but just want to go over, hey, it's a simulation tool. You want to be able to validate your designs, kind of reduce those warranty issues, and, you know, faster lead times is always good. You want to be able to hit those deadlines. Because, you know, that's probably one of the most important things in regards to the manufacturing.
Well, not just hit the deadline, but make sure also that the
component
works. Yeah.
I think that might be a little more important.
Both are important, but
yeah, exactly. So if you do have any questions at all during the webcast, go ahead and type them into the chat panel at any time, and we'll make sure to address those either at that time or during the dedicated Q&A session at the end. So with that, let's get straight into the content. I think pretty straightforward, and let's get rolling.
All right. Cool. So validating your designs with Nastran In-CAD is just like Nigel said. Just the goals for today, I want to make sure that everybody understands how easy it is to adopt this. You know, if at any point your company decides they want to start adopting validation tools, Nastran In-CAD is a great way to go. It's very commonly used and very well trusted. So we'll show you the ease of use, but something we haven't really done before with simulation is show you some of the accuracy by doing some hand calcs. Don't worry, I'm not going to bring out my TI 89 or 83, depending on what kind of experience you have there. You might have used some of those before, but we will go into that, as well as we'll start off basic right now with the setup of a static stress analysis. There's a lot of different types of analysis you can do. We'll have some more sessions on this for sure. I'm sure you'll see some of that coming soon from Nigel. We'll make an edit to the design and finally be able to look at the results of it and be able to decide where we want to go. So that's the goal for today. And really quick, just so that everyone on this session understands what Nastran is, where it came from. It's a piece of software that came from NASA. So therefore, you see here in bold, NASA structural analysis. So it is a very tried and true popular solver that runs right inside of Inventor, SolidWorks, and Pro E Creo, just as Nigel mentioned. And let's remember why we're here, right? How is this going to help you? You know, for some of us, sometimes some of these tools in Inventor, it's really nice. It's fun to play with. I kind of CAD geek out, I guess you might say, and be able to use some of these. But really what it's going to allow you to do is explore your options early, right? Be able to try and reduce, or in some cases even eliminate, the physical prototypes. So that's a great benefit, of course, being able to validate your product before you get it out. You know, a lot of us want to avoid, you know, warranty issues or field failures. I know I've talked to some of you that are on this call today, and unfortunately that's something that's real, right? I want to try and avoid this as much as possible. Something I use a lot is over-engineering, right? We're all used to doing that. Just make it thicker, make it bigger.
When in doubt, make it stout.
There you go. But at the same time, did I over-engineer it enough? We can still have a field failure there, right? So we can definitely do those things within Nastran In-CAD. Real quick, I'm not going to teach everybody here the entire. I'm not going to spend a half hour on the basics of FEA and how it works.
Concepts.
Yeah. So if we look at it this way, you look at the one on the far left, right, where we're trying to get the how much is this going to be able to handle. It's pretty simple. There's simple equations to be able to figure this out. A lot of us on this session might already know that. We had some up on the board just a while ago. As the design gets more complex, though, or as you start adding more features to it, sure, the one in the middle we see here, we can still calculate that. It's not impossible. Even the one on the far right, yeah, we can calculate it, but it's going to take you a little bit longer, right? So we want to make these things easier, right, so that you don't have to wonder, should I do this, should I not? Just go for it. You have the tools embedded inside the CAD tool. So with that, I promise just a short introduction to make sure we're all on the same page about what it is. So we'll go into the live demonstration, and we'll start with this cantilever beam. So what we'll be doing in here, well, this is the first example we'll be doing. After that, we'll do a fork crown for a bicycle. But in this case here, if we were to calc this out, it's not too bad. I think we did it yesterday, right, Nigel? It took us, what, 10, 15 minutes or something like that?
Yeah, we have to remember what some variables were from college, but
a little rusty, but not too bad, right?
Yeah, we figured it out eventually.
And so we plug these numbers into the equations. I'll pause it here in case some of you like to do some math here for fun. But these are the values we came up with, right? 29,000 psi at x equals 0, meaning at the beginning of the cantilever beam, and a max deflection of 0.067 at the far right at 10 inches on the end. So we'll start off by simply doing this simulation first. So if we go over into Inventor, I'll take this time also to introduce you to Nastran In-CAD completely, show you where it's at, how it works, and some of the tools and features it has inside of it. The first thing we're going to notice is we go to environments, and right inside of here is Nastran In-CAD, Autodesk Nastran In-CAD. So it is a add-in where you're able to just click on here and be able to go into this environment. As we go into this environment, it's a familiar interface. And if anybody's ever used some of the simulation tools inside of Inventor before, it's actually very similar. As a matter of fact, we can import results from the stress analysis in Inventor. Inside of here, the first thing you're probably going to do is take a look at the actual analysis, what kind of analysis we're doing. What we're doing first here is linear static, but this does open up a bigger window where we can actually do frequency analysis. We can also do thermal. That's a big one right there that a lot of people didn't do because we simply didn't have that before. Now we have that embedded in Inventor. We can also do nonlinear, so we can do plastics, for example, in here as well. So with linear static selected, we're good to move forward here. And always the workflow when you're doing simulation is you want to work yourself from left to right, as we almost always say, I think, when we do some of these sessions. First, we're going to apply a material. On the left-hand side, you notice idealizations here where basically we're able to tell it, is this part going to be a solid? Is it going to be a shell? Are we doing line elements? So you have those capabilities right inside of here. We notice that it captured that it's already a solid, and it already had, we have a generic material right here. So we don't want to do that. We want to do, I'll do alloy. By the way, if you remember when we saw the calculations, the values we saw in there, the one we're going to choose from is pretty close to what we have. So we're going to go with alloy steel. We were at 30,000. This is 29,000, but that's really, really close, right? So we'll go with that. We could come in here and type it in and type in Poisson's ratio as well instead. I could have still used generic for that matter and typed in the values that I know that I'm going to need for this particular simulation. All right, we'll go ahead and apply that. Now that we've applied the material, we can move on to constraints and loads, the setup portion of it. Notice just really quickly, a quick mention, there is structural members here. So if you use frame generator, any of you out there that use that, you can actually pick this button and it'll pick up all the structural members as well, so you don't have to worry about thin bodies. All right, let's set up the constraints. You'll see here there's some quick options to kind of get you started in case you needed to. You can always pick these boxes if you want to on your own. And notice also there's symmetry here. So if you have a part that's taking, usually we use this at least when it's taking a long time to solve and there is symmetry within the part, we'd usually use one of those. In this case, we want to completely fix according to this face here.
Yep, and as you can see there you can like manually select the degrees of freedom up there. Above the cute little pictures, there's 6 boxes for checks. And if you have a very particular way that your product moves, or this is gonna predicted to move, you can go ahead and set constraints that way as well.
Exactly. So now that we've added the constraints, we'll take a look at the load. And we're going to apply the load, if you remember, on the right-hand side here. And we're going to go negative 1,000 so that it goes down. Notice that you can over here tell it the direction according to the component or normal to a surface or to a geometric entity. And you have more than forces. Again, you can do more than linear static, right? This is just an introduction to linear static first. But if there's moments, gravity, depending on what type of simulation we're running, of course, we have different options.
Yep, you can even get into like heat flux and stuff with that as well.
Yeah.
Load doesn't necessarily mean force.
Or load curves for that matter
Exactly.
too. All right, with that applied, the next step is, since I don't have an assembly, I don't have to worry about the contacts here. So I'll go to mesh settings. And we'll notice that it's 0.3 right now. Well, you know what? We'll go ahead and go with what it's suggesting right now and take a look at how many elements. Typically, and this is something we usually cover in training, which we have available, we want to get at least about 3 elements across here. So not too bad. We'll go ahead and start there, and we'll decide if we want to refine it further in just a bit. Now that we run the mesh, we've gone ahead and done the constraints and loads. We'll go ahead and hit run. And just a few seconds here, we'll be able to get the results from this cantilever beam. All right, we'll get the results by going to contour here, and that'll bring up a nice little toolbar on the left-hand side where I can tell it what I'm looking for. So if it's stress I'm looking for, I can go over here and say solid von Mises, for example. Go to the PSI. We'll go to a right side view and see that, oh, look at that. It's actually really close to the results we got, 29,370 approximately. Not bad. We got 29,000 before. Is that right, Nigel?
I believe that is the case.
Yeah. Yeah, looking at my PowerPoint here, definitely right. So with that said, did we want to get closer results? Oh, you know what? Before we do that, I apologize. Displacement. It was one of the other ones. So if we come over here, switch to displacement, we can see the total in different units, by the way. And we can see what that displacement is, which was 0.067 before. Look at that, 0.0669. That's pretty close if you ask me. I'm not even going to calculate the margin of error on that one, right?
Exactly. And I think we're using as the elastic modulus 30,000, or sorry, 30 times 10 to the 6th. In this case, we use like 29 times 10 to the 6th or something. So, I mean, just that change in elastic modulus probably gave us that. But
yeah,
definitely you want to be sane when doing this. I know that was one of the, doing a sanity check is always one of the big things when I was doing simulation initially, is like, hey, based on my constraints, based on my loads, what do I expect this to do? Obviously, if in this situation we saw there was displacement on the left side of the beam, we'd be a little concerned. We'd be like, did I set this up properly? Because it's supposed to be fixed, right? So if you saw maximum deflection somewhere not on the right side, you got some issues somewhere in the setup, I'd assume.
Yeah, no, yeah, it's definitely good to do a sanity check. Of course, for those of you that are experienced and seeing how these things react, that always helps, of course, as well, too, right? Right now, I just changed the mesh setting to a little bit smaller, 0.2 actually. So we're probably gonna get slightly different results, but still pretty close to what we had before. Sure enough, 0.067 is what we're getting now. So as you see here, as I tightened up the mesh, we're gonna get better results in this case.
Yep. So essentially what FEA is doing is, if you're not familiar with the concept, it's breaking down this beam into all of these little segments, and it's calculating them individually and then compiling them all as a result. So the more elements you have, right, the more refined your mesh is going to be, the more elements it's going to compile, and the more accurate your result is going to be. Obviously, you can do this to a fault. If you put like infinitely many meshes in there, it'll take longer to compute, right? So that's just the kind of trade-off that you have in regards to simulations. Like, hey, I want my mesh to be fine enough so I get a consistent answer with what I'm expecting, but I don't want it to be too fine that I'm blowing up my computer every time I run the simulation.
Yeah, a lot of times you just want to get really close, right, and start getting a feel for what's happening here. All right, so we'll finish this one right here. Again, I wanted to show those results. Again, if we look at the PowerPoint here, we'll see these are the results we got, and we got really close to that. So I'm pretty happy with it and feel like I can move forward with this design if I wanted to start making some changes.
Yeah.
All right. If we go back to Inventor here, what we'll do now is we'll escape this one and we'll go into the fork crown assembly and show you how you can start making changes and be able to move forward with your designs and make more informed decisions.
Yep. So hopefully, just real quick here, Jorge, hopefully that last example helped answer the question of, you know, how accurate is this thing actually? Is the engine that they're using going to give me results, you know, that correlate pretty well to real life examples? And it does. We just wanted to use that as a very simple example that we could hang calc out something that, you know, most engineers would be able to do pretty much in their sleep, and, you know, show that, hey, this tool actually gets, you know, within a couple % of the actual results within a reasonable mesh.
Exactly. So with this one here, this is the assembly of a piece of it. That is, of course, I could do an assembly as well. Right now, we'll keep it straightforward at the one part, but we could come in here and use contacts and make sure that everything's set up with this sub-assembly or more if we wanted to. Sometimes, again, if you just want to get a rough idea, it's good to open up the part, apply it, and see what works. We would still be able to use levels of details inside of Inventor here to exclude everything else in just the one part. I personally like to work within the part itself whenever I can, and especially as I'm starting this design and starting to decide what I'm going to do with it. So with this part, I'm going to run it as is. This is the original design we came up with, and I'm going to go over to environments again and go to Autodesk Nastran In-CAD and start setting this up. I'll notice that aluminum 6061 is already in here, so that's because the part was assigned a actual material, and we'll see that up at the top of the actual Inventor screen here, aluminum 6061. So it picked that up for us. We don't have to go select it again. Now that the material is set up, I'll do the constraints as I mentioned before. We want to go ahead and do that, and we can select more than one surface at a time to fix it by those two right there, and apply the load in the center, and again we'll go negative, so it goes down 5,000 in this case. Notice, by the way, there are some nice tools here at the bottom that I'll just take a quick moment to show you. If I wanted to add another one that was just like this, I can actually do this create duplicate. So if you did have multiple holes that had the same type of load that you wanted to do, you could do that. That comes in really handy with a lot of the other tools that are inside of Nastran In-CAD. Again, this is just an introduction, and we'll go over some of that when it becomes more relevant too. All right, with the load set, constraint set, we'll look at the mesh settings that it's coming up with. I'm pretty happy with that element size for now. A lot of times, you know, you can go ahead and just go with the default and try that first before you decide what you want to do. You know, if you start to notice there's a lot of curvature, maybe you need to bring it down a little bit more, maybe add continuous meshes instead, remove fillets and so forth. You can make those decisions and go back and forth between the model and also going over here into the simulation environment. Let's go ahead and run this. So we literally looked up beforehand before we got on here. We verified again today, and the maximum yield strength was 40,000 psi. We came up with, right, Nigel?
Like that. Yeah.
So knowing that, we'll take a look at the contours here and be able to decide on our own, is this part gonna, you know, be okay or not? And so we go to stress, solid von Mises. We see that the maximum here is definitely under 40,000, right? So this is what we're talking about when I mentioned making better decisions, making your product better. And this is one of those cases where I want to try and make this part as light as I can, reduce the weight for a bike, right? Especially if any of you have ridden a bike and had to lift it, I'm sure you want to try and minimize that as much as possible. I can now decide, well, hey, maybe I want to try a different material. Maybe I want to make this just a little bit, a little less thicker, a little thinner, that is. We can make those decisions right now and see what would happen. So what I'll do right now is I'll finish the Nastran In-CAD environment, go to my sketches, and start making some of these changes. So I'll basically make this thinner by simply typing in some smaller values here for the top radius and the bottom radius.
And this is where it gets super awesome, right? So Nastran is built into Inventor, right? It's using the same Inventor interface. Before, when, like, say you're using a supplementary simulation tool that might not be built into your CAD tool, you're gonna have to go back to your CAD guy, have him make these changes, re-export the model, send it into your simulation, reset up the simulation, and then run it again. It's not the greatest workflow. I know that I've had to do that in the past, and it's not fun. So in this case, you know, it's built into Inventor, right? So any of those changes you're making to the model go live directly into the simulation, because, you know, it's a linked file. Jorge, you want to elaborate a little bit on that?
No, that's exactly right. You know, we've used some of the tools in the past that are still great tools, but there is that small disconnect, right? Or you have to go back and update it, hit a button or something here. It's inside Inventor or SolidWorks or Pro E. So I go back, make the change, come over, it's there. All I have to do now is generate the mesh again, assuming, of course, those surfaces are still there, right?
Right. Yeah, obviously, if you got rid of those holes and your constraints were to those holes, you might have to do a couple of things. But if it's small geometry changes, it should port straight over.
Absolutely. In a few seconds here, I was able to rerun this again, see what the results will be. And hey, is it still within the limits that I'm looking for? It's getting a little closer now. We're looking at about 31,000 when the yield is 40. But now I can start to make that decision and say, well, maybe I went a little too thin. Or maybe now when I go and use some of the other tools inside Nastran, like fatigue analysis, another great tool to be able to find out how many cycles this is going to last, right? No longer guesswork has to go into this, or much more hand calcs for that matter. We might do one at the beginning just for a quick sanity check, but by all means, not a full-blown hand calc or having to send this out. You might still send this out, by the way, right? But now you have a better guess instead of having multiple iterations going back and forth. I know we've spoken to a lot of customers, and I've seen some of you here on the call that we've spoken to where, hey, I still have to send it out. That's fine. Go ahead. That's great. But now you don't have to go back and forth. So a physical prototype or sending it out is not as costly as it once was.
Right. Yeah. Say, you're making something super, super complex, and you didn't use simulation to validate that design. You created a prototype that might take, I don't know, sometimes upwards of weeks to generate some of these prototypes.
Absolutely.
And that fails. You might lose weeks in that case, as opposed to, just throwing it into one of these simulation tools, spending a couple hours maybe, making sure that it's going to work to your needs before you, invest time and materials into creating some of these prototypes.
Exactly. So I hope you all saw how easy that was. Again, this was an introduction. There's a whole lot more inside of Nastran In-CAD, but it's very capable. We saw the proof here by doing the hand calcs to get a sanity check and feel that we're comfortable with these results. I think nothing really drives it home than that. I know when I was first experimenting with Nastran In-CAD, when I got to see that I was close to the results, that's a really good feeling, right? And so, before we wrap this up real quick, I got to really say that, when you look at reporting and you look at studies that have been out there, like from the Aberdeen group is one that we've mentioned before, people that take on simulation are 17% more likely to actually meet their product launch dates, because now they can do some of this up front, right? Instead of having to physically prototype, where you can either minimize or eliminate that. And they've also been able to decrease the overall development of, time for the actual component, right? Or design, I should say. So you're able to get it done faster. You're able to save time so you can move on to more projects, right? More things that are going to be meaningful to the company. And if you look at Nastran and what we just saw today, don't forget that the workflow basically is you have your geometry, you're inside of your CAD package, you're able to assign material, create a mesh, apply loads and constraints, and view those results all within Inventor in this case, right? So that's the general workflow when you're going through this. If you try and run it and you come through some hurdles and it's erroring out, it'll usually tell you it's one of these things. Otherwise, it might just be something that was applied wrong, or a constraint that was wrong or something like that. But it's very easy to get through. It's going to help everybody be able to modify, make suggestions, and make better products. Really quick, again, it doesn't stop there. Like I started mentioning, right? You can do buckling, for example. You can do nonlinear for plastic parts, and even heat transfer. So for those of you that, I know I've talked to a lot of you that are on this call that have wanted to dabble in this, Nastran In-CAD has it, right? You don't have to get a third-party product somewhere else or have to get out of your environment. It's all right inside of there. So with that, we'll open it up to Q&A. Don't forget, though, that if you want to get started on this, while some of you type in questions here, we do have a class now offering for this. That's provided periodically throughout the year. The next one coming up is September 11th and 12th. It's a 2-day class. Gosh, to me, Nigel, to be able to adopt something like this so quickly, get started, that's a heck of a deal there. you'll be able to get started in adopting the software really quickly to be able to get your products done faster and more efficiently.
Yep, certainly. And those classes are available, I believe, like once a quarter.
That's
If I
right.
want to, yeah, I think that's what it is, once a quarter.
And they're in our Bray office, or you can attend online as well. I know we have a lot of AVA users here who are, either out of the country or, in different parts of the United States. So, yeah, do feel free to take advantage of this great offering we've got here that's starting in September.
Certainly, yeah. Just geography is not going to be. There's not a boundary in this case. Yeah. A boundary condition, maybe. I don't know. Maybe we're getting a little too simulation technical.
Yeah. If I had a drum here, I'd
yeah, some cheesy engineering jokes for some people, right? I'm looking at all the people in this room right now, shaking their heads at me. I'm sorry. So if you have any more questions, go ahead and type those in. I'll go ahead and address a couple of these real quick. So a couple of the questions are, there's a bit of confusion in regards to the built-in Inventor Sim and Nastran In-CAD. The major differences between the two and when to use one over the other. I know that's pretty loaded, but Jorge, if you just want to check over a couple of those things.
Yeah, there is a matrix available online. Actually, I think I have one here to show. There is a matrix that you can find online. We can provide you the link for that. But basically, what Inventor Professional will do is the static stress analysis. It will not do nonlinear materials such as plastic. An Inventor Professional does not have the fatigue analysis or the heat transfer. All of that is inside of Nastran In-CAD. Again, this matrix is available and gets a little more detailed into it, but those are kind of the basic ones. Oh, and modal analysis is in both as well. So those are kind of the big ones. Oh, and Inventor Professional does have dynamic simulation as well. It works quite a bit differently though. Personally, I think Nastran In-CAD works a lot easier for doing some type of dynamic simulations.
Yeah, so if you have any particular questions on what's in there, what's not, feel free to look at the matrix. So, just go ahead and shoot us an email. We'll be more than happy to help you figure out if what you're looking for is included in built-in Inventor or built-in Nastran In-CAD. We can go over some of that with you guys.
Right.
But generally, some general guidelines is fatigue, Nastran, heat, Nastran, static stress, both, dynamic, quote unquote, both.
Yeah.
One's a little bit easier than the other, like Jorge mentioned. Let's see. A couple of questions about meshing in regards to the mesh refinement. Can you refine the mesh at certain areas of your model as opposed to just like globally?
Absolutely. That's a great question. So when inside of Nastran In-CAD, I'll get out of the results tab here, and in the mesh control section, this allows you to actually select on different faces and be able to tell it what you want that element size to be. You can also do a part split on some of these components if you have a specific area you're focusing in on. But generally speaking, most people need to come in here, be able to select these faces and control that further. So you definitely can do that inside of Nastran In-CAD.
Yep, and the reasoning for that, for those of you who don't necessarily know why you'd want more elements in a certain place, is in areas of note where you think there's going to be a lot of deflection or a lot of force. You want to make sure you get a very accurate answer there. You're going to want more elements, like I mentioned, but maybe you don't necessarily want more elements in like a very robust area of a shaft that is not going to break, just based on the loading. You're going to overload your computer if you just globally go super small mesh, and it's going to take forever to kind of complete some of these things. So you kind of lessen some of that computational requirements by only putting the small mesh in certain areas.
That's right. And these are all things we'd cover in training too, by the way, right? So when you take training, you're not going to just be going through just standard tutorials like you would on your own. There are tutorials, as you see here on the top right of my screen, but there's nothing like being walked through it, right? And being able to give you some tips. There's a couple things that I definitely know I like to do when I'm setting this up when it comes to like assemblies and contacts and making sure that that all the contacts and all the constraints and loads are working together so the component moves as it's supposed to, that we like to share when we do training.
Definitely. And then what does the licensing look like for Nastran? Just questions like how do I get this?
Right. So it is a multi-user seat, kind of like a network license. So you'd go ahead and put the license on a server. You can put it on a dedicated on your own machine too, by the way. You don't have to have it on a server, but doing it that way does allow more people within your organization to be able to use it, right? So, you know, a lot of times one thing I hear is, hey, this is great, I love it, but I'm not going to use this 5, 6, 10, 20 times a year sometimes. Maybe it's just 5, 4 or something like that. Well, what if you expand that to other folks in your company, right? To be able to give them that upfront design preview, if you will, instead of having to wait till the end.
Yep, certainly. We got a couple more questions. David, I'll follow up with you afterwards on that question. That's probably going to take a little bit longer to answer. We probably also need to look at that model as well. And then let's see here. Composites, is that a thing we can work with in Nastran?
We can, yeah. You can actually do composite material inside of here as well.
Okay, cool. And then in regards to the output for Nastran, Jorge, we saw von Mises stress, we saw displacement. What other things can you get out of the results for something? If you just want to jump into contours real quick.
Yeah, if I go to the contours here, basically this is all the different types of things we can see for the results. So there's displacement, there's stress, strain, reaction forces, and then even in this other section, that's where you'll see things like safety factor, for example, solid status. We're seeing here convergence, and if there's any convergence errors, we'll see some of that here. And depending what type of simulation you're running, of course, this will change. So like if you're doing fatigue, then it'll show you the life of it, how many cycles before it actually breaks. Those things will start to pop up here.
We're not going to get like any heat flux or anything in this situation.
Yeah, exactly, because we're not running heat transfer. And even if I go to the options here, we have some other things we can do, like being able to manage this legend a little bit more. What's the actual minimum and maximum? So I know that aluminum 6061 was 40,000 psi. I could have put that as my max so that if I don't see any red, I'm not even hitting close to that, right? But maybe I want to keep it around 30,000 because taking into mind the amount of cycles it might go through. So we can change those things here. We can animate it and create AVIs from here as well.
Yep. Yeah, and just something real quick in regards to some of the deformation when it shows it, it's an exaggerated deformation of the part. I don't know if Jorge, you can jump to the deformation real quick.
Yeah, you'll see you're seeing that here actually, where I can turn on the deformation options and tell it to be a percentage of the overall part, or if I wanted to display the actual displacement. So that's going to be important, right, when you're looking at the full assembly and trying to see the actual displacement. If it's 0.01, you know, it's not going to be so drastic, maybe a little bit, but as that starts to grow, then this is going to be even more important, of course.
Yeah, so that load doesn't create like this fork piece to be like super jelly, right? It's just a representation of what's actually happening. And you can set that deformation scale, which is really important. I know a lot of people are like, my part, I swear it's not going to move like 4 inches like it shows in the simulation, but that might be because you're showing percentage and not actual deformation.
That's right.
Let's see here. And last question. There's a couple more questions that I'll follow up with people after the webcast. There's a few here that I think might benefit from a larger conversation. And Jorge, I guess you're just changing the color options as I'm just like reading these questions.
Yeah.
Just going through a couple things. That's cool. Maybe you don't like the color blue for some reason, and you want to see this in grayscale. That is an option for those people. The last question here on meshing. Are we limited to TET mesh is in Nastran, or can we go like quads and stuff like that?
Yeah, this just does TETs and quads actually by default. So we don't have the option to change it to like bricks, for example. But really, when you look at some of the information out there, TETs are really one of the best ways to go for a lot of the cases. So where we do have flexibility is just changing the mesh size and saying if it's parabolic or linear. And we saw that when we went to the mesh settings itself. Take off deformed and contours here. And under mesh settings, we get the ability to choose between linear and parabolic as the continuous meshing and element sizes and the tolerance for it.
Yep. So there are some options there. If anyone wants to learn a little bit more, definitely reach out to us so we can go over conversation with you specifically on what your needs are and see if Nastran is the right solution for you. I know a big question that comes up a lot that we didn't, necessarily get this webcast, which leads me to believe it doesn't come up a lot anymore, is the CFD question. So just to answer that question, CFD is not in Nastran In-CAD. CFD is actually like its own software.
Yeah, CFD is its own software, but you can bring in CFD results into Nastran In-CAD. That was new for 2018. Actually, it was a big piece of what people wanted to see.
Yeah, so you can see the results from a CFD simulation in there. Grab those trails and stuff.
Right. Exactly. Especially when you're looking. Well, in this case, when you're looking at thermals, most likely when you want to bring some of that in, right, and get some of your loads.
Certainly. So with that, I'll leave everyone another 30 seconds or so to go ahead and ask any more questions. I do have some follow-ups. Eric specifically, I'll reach out to you, and David, I'll reach out to you as well via email probably later today.
Yeah, if anyone's interested in the training, you can go to our website, katif.com, and if you go to services and you go to services training, that's where you'll find this page and be able to actually sign up yourself if you like. You can always contact us, comment us, leave us a comment if you want to know more information about it. There is an agenda that's available for you as well, so you can see exactly what it will entail. Again, I think it's a really good price here to get you started if once your company decides they want to start adopting validation tools. Yeah,
certainly. I think it's one of the most important, it's one of the biggest stepping stones, right, into just being able to do things much faster.
Yeah.
And I don't know, I always use the term reduce warranty issues. I might have heard that like 50 times in one day once. So I just use that all the time. And it's huge, right? You don't want people to be returning hundreds, if not thousands, or maybe millions of your parts for failures, a year down the road.
And it's easy to use. And, if that example of that beam is a great example of something quick you can do. You can even do that inside of Inventor Professional so you can see what that looks like, right? So I can't stress that enough.
Yeah, certainly play around with it. With some of the tutorial functions, it makes everything super easy. So yeah, feel free to do that. So with that, I think I didn't get any more questions, so I think we'll go ahead and end for today. Jorge, do you have a couple more? Okay, cool. So thank you again, Jorge, for being here today, showing us some Nastran In-CAD.
Yeah, look for more sessions on this. Like I said, there's a lot more in here. I wanted to get everyone started knowing what it actually does, how it works. We'll definitely have some more. If you have any comments on some you want to see, maybe we can prioritize which ones you see first.
Exactly. Yeah, we have one of these scheduled, I think, about 4 weeks out from now. Another Nastran one. It's not with you, unfortunately, Jorge. Gotta get Hav on here every once in a while, right?
Depends on the comments we get back. We'll see.
That's true. Maybe everyone wants to see only Jorge. So we'll see. But next week, just speaking of next week, something that's been eluding us for, I guess, the almost 2 years of AVAs is sheet metal, which is kind of hard to believe that we haven't done one on sheet metal yet, right?
Yeah, I can't believe that.
Yeah, so kind of got through the cracks a little bit. So next week we're going to be covering sheet metal. That's one of the, I think, biggest things that people use Inventor for, or maybe have you switched from that 2D AutoCAD space into Inventor 3D space for, is for things like sheet metal. Being able to bend, unfold, and get your flat patterns out of Inventor. Javier Chavez, one of our application engineers here, is going to show how that whole sheet metal process works in Inventor. And we might also have some really cool special offerings after that class. Still putting something together, but we'll see what we come up with. So if you're interested in sheet metal, maybe you want to learn some more basics on sheet metal and best practices in regards to how to properly build a sheet metal part, or convert things to sheet metal parts, definitely be tuned in next week for that. So again, Jorge, thanks for being here today. Thanks for everyone in this room for being quiet for me this morning. And thanks for everyone for attending. So we'll see you all next week. Thanks.
Bye.